So let's see. Whoops, too zoomed in. It's being very touchy right now for some reason. Um, did I zoom that in or did you? Because I can't unzoom it. Oh, geez, 1000%. It's down at the bottom. It's being kind of glitchy today. It's being very touchy. All right, can you see that okay?
Yeah.
Okay, so position of a particle is modeled by that equation. Find the displacement of the particle. Okay, so what's displacement again?
Um, from the notes, I'm pretty sure it was like it's
X
not like it's the like I don't
X
remember what it was, honestly.
of 5. You plug in 5 in, right? And then you
Yeah,
and then you subtract when you plug in 2. I believe that's displacement.
that's it.
I believe that's all the displacement is. Yeah.
Okay.
Um.
Yeah, it's for like the is it just for like the normal equation or is it like velocity or acceleration or
No. Yeah. Just for this. Yeah. It's x of t is the formula. So it's x of 5 minus x of 2.
okay.
You don't have notes on that?
Um I do. I just didn't like understand them because
What?
I was thinking them in like a rush, I guess.
Yeah. Tell me what the notes say.
They say
It's the short. Yeah, I'm looking it up on Google. The displacement refers to the
I
short
wrote
distance between the particle's initial and final position.
oh, where do you put them?
So the displacement equals the final position minus the initial position. Yeah.
I think yeah, that sounds about what we did.
So yeah, so just plug in. You know how to do that, right? Just plug in the value.
Yeah.
Your store button on your calculator would be the easiest.
Yeah.
Okay, so the average velocity of the particle um, is. Let me make sure. I think there's a formula for that, right?
Yeah. It's like x minus
Total
t.
displacement by the total time. So you take the total displacement from 5 to 0, and then divide it by 5 minus 0. So that's the average velocity because this is the distance it traveled and this is the time it traveled, right? This is the
Yeah.
distance and this is the time. So the average is just that. What is the particle's velocity at time t equals -2? So the velocity,
That's like an easy one. It's just like
yeah, you got
calculate the derivative and
good.
plug it in. Yeah.
Yep, perfect. What is the particle's average? Same thing. Oh, average acceleration on that. So the average velocity on the particle is that equation. So the average acceleration would be this equation for the same reason, right? Does that make sense?
Right. Okay.
What is the particle's acceleration at t equals -2? You good with that, right?
Yeah.
Okay, is the particle speeding up or slowing down at t equals -2? So um speeding up or slowing down. Do you have notes on this? I feel like there's an easy way to explain this.
It's like oh my God. I'm sorry, Mr. Dwyer. My note, I don't even know where. There they are. Okay. Um, same signs. It's basically if it's the velocity and the acceleration. Like when you do the number lines, and you put like the positive and negative signs between the values,
Yep.
it's if they have the same like so like okay. So if it's like for
Yeah, you're
velocity,
right. So take the velocity at time two and see what the sign is, and then take the acceleration at time t equals -2 and see what the sign is, right?
yes.
So it's speeding up if they both have the same sign, and it's slowing down if they have opposite signs. So take these signs, consider what those are, so you know how to do that, right? And if they
Yeah.
have the same sign, then it's speeding up. Got it? And if they have
Yes.
opposite signs, it means it's slowing down. That's how you tell.
Okay.
Okay, makes sense?
Yeah.
Okay, and on what interval is the particle's velocity increasing? Well, the velocity is increasing where the derivative is greater than 0. So do your sign chart for your velocity, right?
Yeah.
And then so find your zeros. I don't know how many there are. Two. Would there be two? Was this a cubic originally? Yeah. So let's do that. The particle's velocity at t equals -2. So this would be 6t squared plus 18t plus 6. So if I factor it out, so that's at -2. Well, we won't do that work. We'll just do this. So your equation down here is 6 6t squared plus 18t plus 6, and we're trying to set that equal to 0. So let's cancel out a 6. So that's t squared plus 3t plus 1. All right.
Yeah.
Which doesn't factor. Um, wait, on what interval is the particles? Sorry, I didn't read that correctly. Is the particle's velocity increasing?
Oh, did you do the acceleration?
Velocity increasing. When is it speeding up? Yeah, no, I did it right. Velocity increasing. Yeah, no, that's right. So we're going to have to solve this with the quadratic formula. -b plus or minus the square root of b squared minus
Let me
4
see.
ac all over 2a. So it's -3 plus or minus the square root of 5 all over 2. So
Ugh.
this will be -3 minus root 5 over 2. And this will be -3 plus root 5 over 2 right here. Yeah, got what I'm doing there? So
Yeah.
we got to determine these three regions. So first of all, the square root of 5 is between the square root of 4 and the square root of 3. So it's going to be 2 point something. So this is going to be negative something. And then this is going to be also, they're both negative values. That doesn't really help us. How about we put -3/2 in the middle and test that point? So that a point in between these is -3/2. A point to the right is 0. And a point to the left is, let's just say -5 to make sure that we're far enough to the left. Get what I'm saying?
Yeah.
And
Ugh.
plug those into here using your store function and your graphing calculator. So this is going to be positive over here because it's just +6. -3/2. I'm just going to do it on my calculator right here. I've got it. So it's -3/2 is -1.5. I'm storing that for X. You remember how to do the store func feature?
I'm pretty sure I do, yeah.
So I just, in your graphing calculator, just type in the number like negative 1.5 and then hit the store button, which is lower left-hand corner above the question mark, and then hit the X and then hit enter. And then go ahead and just type in 6x squared. I know you can't see this, but trust me, plus 18x plus 6 and see what your answer is. That's going to be a negative value. And then plug in -5 by just storing -5 for x, -5 store x, enter, arrow up, get that same formula you just plugged in and hit enter again. And that's going to be positive over there. So where is the velocity increasing? It's increasing when it's positive. So it's increasing from negative infinity to -3 minus √5/2. And it's also increasing from -3 plus √5/2 to infinity. So those are the two places it's increasing. Good?
Okay.
Makes sense how I did that?
Yeah.
All right, you want to turn this other one around? Or are you good with this one now?
Um, I'll be fine with this one, I think. It's just like,
Is that a different question? I don't see what the
well,
question.
it is a different question. Okay, so
Well, let's do number 62 first, then we'll come back
you
to
can do
that.
number 62 for shit. Yeah, sure.
Find the value of each limit. The limit as x goes to pi/3. Well, all you have to do is just plug in pi/3 for all the x's for this one. So just plug pi/3 in for all of these. So think of your unit circle. And that will be the limit. Anytime they ask you
Okay.
limit, if you can plug in the values, just do it and be done with it. So pi/3, if you remember, it's this one, it's the bigger one. So this is √3/2, and this is 1/2, and this is 1. That was our triangle on our unit circle, right? So what is the sine of that angle? The sine is the opposite over, it's √3/2 plus 1/2 plus 2/√3. It's just going to be the reciprocal plus 2 plus the tangent is going to be √3, and the cotangent is going to be 1/√3. So that's it, and then it's just a matter of simplifying that. So let's get common denominators, which would be, what's the common denominator for this?
Um,
It's going to be two
yeah,
2√3.
yeah.
So this has to be multiplied by √3 over √3. This has to be multiplied by √3 over √3. This has to be multiplied by 2/2. This has to be multiplied by 2√3 all over 2√3. This has to be multiplied by 2√3 on the bottom and the top. See what I'm doing here?
Yes, yeah.
Just 2 and
It's for
2.
the common denominator. Yeah.
Yeah. So this is going to be, change back to white because it's easier to see. So this is going to be 3. Everything's going to be over 2√3. So this is going to be 3 plus √3 plus 4 plus 4√3 plus 2√3 plus 2, which equals, add our √3s together, there's 1 plus 4 plus 2, which is 7 there's 7 √3s that I add together, and there's 7, 8, 9. 9 plus 7 √3 all over 2√3 would be your answer.
Okay.
And then actually, hold on. We should probably rationalize the denominator. Remember doing this?
Yes, I
So
think so.
multiply the top and bottom by √3 because we don't like a radical in the denominator. So this would equal 9√3 plus those √3s, when they multiply, they become 3. So 21 all over. And then this is just 2 times 3. And actually, we can simplify this some more. So I can cancel a 3 out of all of these, and I'll get 3 root 3 plus 7 all over 2. So that's the simplified answer, assuming I didn't make a mistake. Got it? And usually it's better to write the radical portion behind it. So writing it like that is probably the best way to write it. That's how you would see it written somewhere. Okay.
Yeah.
Questions about anything I did there?
No. It makes sense to me.
Yeah. So what was the formula here?
There should have been a fourth image I thought that I shared with you.
Oh, sorry. I don't think I got that one. Do you have
Okay,
it? Do you want
maybe
to just,
I'll send it to you. Let me put it, bro. Everything's
maybe, is it number
uh
58? Was this number 58? Oh, it does say plus one more. Okay. So there is another one in here. Okay, I got it. I got it. It was hiding in my attachment.
okay.
Okay, let's see. It is this one right here. All right, can you see it okay? Which
Yes.
question did you want me to go over?
Just 57 and 58, please.
Okay, use the intermediate value theorem. Determine if the function has a zero on the interval. So the intermediate value theorem says that if you take the two endpoint values, so if you take f of 0 and f of 1, if you find out what those values equal, so f of 0, I'm just plugging that in as -1, and f of 1 is 1 plus 2 minus 1 is 2. So it says that using the intermediate value theorem, determine if the function has a 0 on the interval. The answer is yes, it does, because it is
Oh, yeah, because
continuous. It's
it has
continuous.
to go through.
And it has to go through all of the values between 1 and -1 and 2, and 0 is between -1 and 2.
Yeah.
That's what the intermediate value theorem shows you. Okay, 58, it says using the intermediate value theorem, determine if the function blah 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 has a 0 on that interval. So same kind of thing, right? Plug in 0. So g of 0, what would g of 0 be? That would be
Uh
0 minus 2. What's the cosine of 0?
1.
It's 1. So it's -2 minus 1, which is -3. And then g of pi would be pi squared minus 2 minus cosine of pi is cosine is x coordinate, pi is 180, -1, right?
Yes.
So that equals pi squared minus 1, which is definitely a positive value, right?
Yes.
So between 0 and pi, um, they're determine if the function has a 0 on the interval. It does have to have a 0. Now, the only other tricky thing is make sure that it is continuous on that interval. Make sure that this function is continuous, because part of the intermediate value theorem said that in order for you to be able to use it, you have to prove that it is, what is it, differentiable and continuous, or just continuous? I forget.
I think it's just continuous.
Yeah, I don't remember. You have to look up. You have to look it up. I don't remember off the top of my head. But make sure, let's see, this is differentiable, so that's fine if that was a condition. And it is continuous. I can't imagine where the domain, like what values you can't plug in. It is continuous. If this was a tangent, you might have a problem because the tangent isn't defined everywhere. It's undefined sometimes, right? So I would say this is yes as well. Okay.
Yeah.
All right. That